So the next thing we want to look at is making it do something. Now there's two ways that you will generally interact with commands. We will make sure we touch on both of those. One way is through issuing commands. And so when we say issuing commands, we mean, hey, when I do this, do this. The other way is through default commands. Not every subsystem will have a default command, but some subsystems will have a default command. And a good rule of thumb is there something this subsystem should always be doing? If the answer is yes, a default command is a good option. For the drive subsystem, is there something the drive subsystem should always be doing?
Yes.
What?
Driving.
Should it always be driving?
No.
When should it not be driving?
When it's not commanded to.
When no inputs are given to it to drive.
No inputs are given, okay? But what is the difference between giving an input of nothing, no input, and giving an input of all zeros? Are those not the same thing for driving? So when you're not giving the drive subsystem inputs from your joystick, you are giving it inputs. You're giving it 0, 0, 0. So even though it's not moving, it is still driving. It's just driving at a speed of 0 forward, 0 left, 0 counterclockwise. So even when it's not driving, it's still driving. It's just not moving, because not moving is driving with 0 speed. So because of that, I would argue the drive subsystem is always doing something. It just may not always be moving. And so for that reason, we do say that, okay, we do have a default command. And so what we're going to do is in configure bindings, we'll do it in configure bindings, we're going to set up the default command. And here's how we do that. We start with the thing that needs a command, and that's the drive subsystem. So drive subsystem, and we want the drive subsystem to do or have something. So what's the special symbol we do when we want something to do something?
No, dot.
Dot. We use equals to create, we use dot to do. Dot, let's see what we got. Add child, probably not that. Get current command, get default command, okay, that's something. Register, remove default command, run in, run once, set default command. Okay. And then it'll populate some stuff in there, you can delete that. Okay, so we've got the set default command. Now we've got some options. I'm gonna make sure I pick the right one. So I'm gonna tell you to do something without fully explaining why we're doing it, because we'll hopefully look at later why we do it. So I don't want that one. I don't want that one. I think we want the run. Okay. So we're going to type commands, capital COMMANDS, dot run. And now in the commands.run, we're going to have to add what's called a runnable. And again, we're going to do a little hand wavy right now, and we'll explain in a little bit what all this stuff means. We're going to do opening parenthesis, close parenthesis, hyphen, arrow, squiggle, squiggle. So you should see something that looks kind of like that. It looks weird, but it shouldn't be red. Then, after the squiggle, we're going to do comma, space, and we're going to add
That makes an arrow.
drive subsystem. So right now, this is what you should have. Drive subsystem dot set default command, opening parenthesis, commands dot run, opening parenthesis, close parenthesis, hyphen, greater than, curly brace open, curly brace close, comma, drive subsystem.
Does that just make an arrow pointing from the
That is making an arrow. Yes, that is supposed to be an arrow.
I knew it.
Okay, so the next thing we want to do is go into the curly braces and press enter. Now, one thing to notice, you've got a set of parentheses and you've got a set of curly braces. What does that make you think of?
Inputs and outputs and a
What's something else in Java that has a set of parentheses and a set of curly braces?
method.
Method. This is a method. It just looks different. And so the method we're going to do, we're going to actually pull some data out now. Double forward speed. Where are we going to get our forward speed from? What thing will tell us how fast to go forward?
Motor controller.
Well, we want to tell the motor controller how fast to go.
Oh, joystick.
Our joystick. So we're going to do my joystick dot, and now there's three handy dandy functions on here. We've got get X, get Y, get Z.
One.
Would-
X,
So why do you want X?
because X is our forward and negative forward.
Yes, but no. So X is forward for a robot. X is not forward for a joystick.
Y is
Y is, sort of.
so confusing.
So this is a coordinate system problem, right? On a joystick, forward and backward are your y-axis. The way WPILib has defined a robot, forward and backward for the robot is the x-axis. So that's why here we're trying to use words like forward and left and right to kind of abstract away and not care about x's and y's.
It's so stupid.
So we do have one more problem though. Forward on a joystick is the negative direction. So we need to make this negative. Now we want to get our right speed as well. How do we get the right speed? If you had to guess.
Oh, get X.
Get X.
I was trying to type.
And this one is nice because right on a joystick is positive. So we're good there. And the last thing we need is the counterclockwise speed. My joystick dot, we got one more get, and that's going to be the get Z. But we do want to check one thing. If we hover over get Z, it just says it returns the Z position. We don't know if that's positive or negative, so we're going to assume it's positive right now, and we'll figure it out in a minute if it's not. So right now we have pulled out the three speeds we want from the joystick. And we're going to give them to what? What is the thing that's going to be doing the moving? Well, it's not the whole robot.
Just the
No,
controllers.
motors.
The individual motor controllers.
Now, we don't care about the individual motor controls. We don't know about those anymore. What's the only thing we know about?
The drive subsystem.
The drive subsystem. So we're going to tell the drive subsystem to do something. How do we tell the drive system to do something?
Dot.
Dot. And what do we want it to do?
Add child.
Add child? Probably not add child. We defined something it could do. What was the method we wrote?
Move.
Not move, but
Drive.
drive. So we're going to tell it drive subsystem dot drive forward speed, right speed, counterclockwise speed. So this file was all the code we wrote to define what is a drive subsystem, what can a drive subsystem do. This was the line we added to create the drive subsystem. And this is the chunk of code we added to tell the drive subsystem, hey, when you're not doing anything else, listen to what the joystick's doing and use that to calculate your speed and set your speed.
So Drew, I got a question on that.
Yep.
It's more the command infrastructure side of things. You're doing drive system dot set default command, and then you give it a requirement of drive subsystem. Why isn't that implicit? I guess.
It's not.
Okay, so if you gave it this default command and some other command required
Yeah, so if you don't explicitly list your requirements, there are no implicit requirements. So if you don't explicitly say the drive subsystem is a requirement, then it will allow another command to run at the same time.
Right, okay.
It's a weird, it's kind of a weird choice, I think. I feel like the default command should be able to infer that, but I don't think it can.
I would assume that any default command I create requires that the subsystem is executed.
I don't think that's a safe assumption. Yeah. So this part here, and so we didn't talk about it yet, one of the ideas in command-based robots is every subsystem can do one thing at a time. You can tell it to do command A, you can tell it to do command B, but you can't tell it to do command A and command B because you don't want to get a condition where one command is telling the motor to go forward and the other command is telling the motor to go backwards, and it creates a bad condition that could damage the subsystem. And so what you have to do is when you do commands, you have to tell it, hey, these are the subsystems this command uses, so that if another command comes along later, it can stop that first command so that you don't get into that bad data condition. Okay, so if we were to test this, how do we test this?
Here.
With what?
You go to the API button.
And we want to do simulation, right? Now, before we do that, though, we need to make sure we have the right joysticks. Let's go ahead and open up Driver Station. And we can take a peek at this joystick before we do anything with it. So make sure if you've got the joystick popping up that you get rid of the one that's not being used anymore. So Ethan, are you noticing anything about this Z-axis?
Yes, forward is negative, backwards is positive,
Forward. What do you mean forward?
pushing the joystick forward.
Oh, that's the Y-axis,
Y. Z, oh,
the twist.
it's slightly going back and forth.
Well, which way is positive?
Clockwise.
Clockwise is positive. So
We have to select no
we will need to
one.
fix. We will need to fix something.
That's gonna be annoying.
Well, it's a good example to talk about because it demonstrates the benefit of like naming things well, because it'll be obvious where the problem is. So Fidel, one of the things
Know that there was a joystick coming.
one of the things we noticed while y'all were looking for the joystick, the Z-axis is negative in the counterclockwise direction and positive in the clockwise direction. So we got to fix that somewhere. So if I look in the drive subsystem, I can see I'm using counterclockwise here. And I can see that drive Cartesian is expecting a counterclockwise speed. So I don't think the problem is here. But if I look here, I've said, hey, the counterclockwise speed is the Z-axis. But if I look here, the Z-axis positive is clockwise. So that tells me right away this is where the, quote, bug is, the defect. I need to make that negative, just like I did with the forward speed. And so again, that's the benefit of making sure you're naming things what they are as opposed to, what direction or what letter they are. So now if we simulate robot code, make sure you've got driver station selected. Actually, don't worry about selecting driver station because we were just checking on that. So we gotta let it do the build, let it launch the simulation. Okay, so what you wanna make sure, once your simulation launches, we'll wanna make sure we move our Extreme 3D Pro over to joystick 0 so that it's reading the values. We also wanna make sure we can see our PWMs. So we go to hardware, make sure PWM outputs are showing. And then what robot state should we be in for the joystick to control the robot? Teleoperated. All right, so if I push forward, notice my PWMs are changing. So if I just push straight forward, more or less straight forward.
Some are getting a full one, and some aren't.
If I pull back, go side, side. but it looks like PWM 0 and 2 are full forward, and 1 and 3 are almost full backwards, right? Well, if we look at the drive subsystem code, 1 and 3 are the ones on the right, and 0 and 2 are the ones on the left. So one set should be inverted. Now, do we know that forward and back are left and right and vice versa for sure? Not without seeing the motor move. We are just assuming that right's moving forward and left is moving backwards. But if it turns out, hey, that's not the case, all we have to do is go in and change these trues to falses and falses to trues. But now, this gives us the idea that we have a robot moving, and all we had to do was hook up that command, and WPI is doing the calculations on the Mecanum drive side for us.
Have some stick drift.
Probably some stick drift, yeah, a lot of things happening there.
Very similar stick drift too. All values for the stick drift are same.
All right, I'm going to close that simulation. Any questions up to this point?